Hello again, starting with number 3 on the 5.7 section review, doing the true-false. So determining whether each question, or each equation rather, is true or false. And if it's false, you have to rewrite one side of the equation to make it true. It doesn't matter which side we rewrite, and of course there's many different solutions you could have, so I'm just going to give you one version of the ones that are false, but there's a couple that you could think of, I'm sure, that we could have done instead. So just starting with A, log of 3 plus log of 7 equals log 21. This is our product property, so when we're adding two logs together, we multiply our numbers, so 3 times 7 is 21, so A is true. Over to B, similar to A, we're adding our logs, log 5 plus log 3. However, the rule again is that when we add, we multiply to get our new log, and in this one is false because they have not multiplied, they added those numbers. So in B, I would rewrite this to say log 5 plus log 3 equals log 15, not log 8. Okay, for C, we have log 16 equals 4 times log of 2. So remember, this is our power property of logs, so this 4 becomes an exponent on the 2. So this really becomes, for C, log of 2 to the 4th power. Now calculating 2 to the 4th power, remember, is 2 times 2 times 2 times 2. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, which matches what's on the other side, log 16. So C is true. I'm just going to erase this here. Okay, so on to the next one. D, log 5 minus log 2 equals log 2.5. So now we have subtraction. Subtraction is the quotient property, and the quotient property says we divide our numbers. So 5 divided by 2 is in fact 2.5, so D is also true. In E, it says log 9 minus log 3 equals log 6. Again, we have subtraction. Subtraction tells us to divide. 9 divided by 3 is not 6. So E is false. And we would rewrite E to say log 9 minus log 3 equals log 3, because 9 divided by 3 is 3 and not 6. Looking at F. So F says log square root of 7 equals log 7 divided by 2. So remember, square roots can be rewritten using our definition of rational exponents. So square root of 7 can be rewritten as 7 to the 1/2 power. So if I had log 7 to the 1/2 power, the power property tells me to take my exponent and put it in front of my log. So this would be 1/2 times the log of 7, which definitely does not match the other side, log of 7 over 2. So F is false, and F should be written as log square root of 7 equals 1/2 times the log of 7 for this reasoning right here. Okay, moving right along, I'm going to erase this over here. You guys already know at this point, pause, rewind, whatever you need to do, go back over and look at what's going on. For G, log 35 equals 5 times log 7. So for G, that is false as well, because again, we would take this 5 exponent and put it on top of the 7. 7 to the 5th power, I don't even have to calculate that because right away I know 7 times 7 is 49, and then I have to multiply by 3 more 7s, so it's definitely going to be bigger than 35. So right away G is false, and I would rewrite G as log 35 equals log of 5 plus, and I'm going to run out of room, so I'm going to put it underneath, log of 7. Because when I'm adding my logs, that's when I multiply my two numbers together. 5 times 7 is 35. So that would make a true statement. h. H is a little bit tricky. So h here says log of 1/4 equals negative log of 4. This one is actually true, and here's why. This negative log of 4, we have to, when we think about something like negative x minus 2, and we think about distributing, we always say that there is really an imaginary negative 1 right here. Well, it's the same thing for our log. There's an imaginary negative 1 that's being multiplied by our log. And when we have a number being multiplied in front, remember that becomes an exponent. So this is rewritten as log 4 to the negative 1 power. And what do we know about negative exponents? They become reciprocals. So this becomes log 1 over 4 to the first, and 4 to the first we know is just 4, so it becomes log of 1/4, which is exactly what the other side of h says. Log of 1/4 equals negative log of 4. So that one, like I said, is true. Going on to I. I says log 3 divided by log 4 equals log 3 over 4. So one side looks like change of base property. The other side looks like was divided. Now if we have division here, then we should have had subtraction here. Well, there's definitely no subtraction. So this is definitely false. Now, which way you want to rewrite it is up to you. You could use the change of base, which is what I'm going to do. So for, what is that, I? The change of base formula says that if I have log of 3 over log of 4, then that's equal to the log base 4 of 3, because change of base is log A divided by log B, and this is always log B of A. So that would be I. For J, the last one here, for J, again we have this number in front, 1.5. I would put that onto 16, and 16 to the 1/5 power, or sorry, not 1/5, 1.5 power, is indeed 64. So J is true. Right? There's our true-false section, number 3, from our review. I'm going to go to the next slide and complete number 4. Okay, so number 4 says, suppose you invest $3,000 into an account that has an interest rate of 6.75%. It's compounded annually. They want your money, triple the money. How long will it take to triple your money? So how long to triple your money? So remember, we can set up an equation here. We have y equals the initial amount we invest times 1, and since we're increasing here, we're going to add our percentage rate to our x power, which represents our amount of time. So plugging in what we're given here, I would have y equals 3,000 times 1 plus, and I'm going to change the rate to a decimal, so that would be 2 decimal places, right? Divide by 100. So we'd have 0.0675. So 1 plus 0.0675 to the x power. Now for tripling the money, that's how much I would have when I'm done. Well, triple 3,000 is 9,000. So my y is going to be 9,000 equals 3,000 times, I can add these two together, so 1.0675 to the x power. And now this just becomes the same type of problem that we had in 1 and 2. I'm just going to divide both sides by 3,000. This is 3 equals 1.0675 to the x power. And now I write my log. Log base 1.0675 of 3 equals x. And when I solve for x, I get about 16.8. So it would take about 16.8 years in order for my $3,000 investment to triple at a rate of 6.75%. All right, so one more, just number 5 coming up. Tune into the next screencast for that last problem.